Hi, my name is Zoe Schnepp, and this is an introduction video to the accessible carbons for water treatment experiment. So I'll just quickly go through the equipment we're going to need for this experiment. We've got three little deli pots here. These are the ones we use are 30 ml capacity, just little plastic deli pots with a lid that can be closed. You then want three vials, or we use actually centrifuge tubes, little plastic centrifuge tubes. These are 50 ml capacity. You just need something basically that's got a lid that you can close. And again, we use plastic just for safety. For each of these, you want to make sure you label them. And for accessibility for someone with visual impairment, we use tactile stickers, so you can actually feel the difference between each of those. What you also want is some water. And a couple of samples of carbon. So we've got activated carbon, and then to compare that, we've got some just barbecue charcoal. And if you can crush that up to be about the same size, so about the same particle size as the activated carbon, there's more details about that on the website. Okay, so we've got all our ingredients. As a preparation for this lesson, what you need to do is get a fragrance oil. And again, there's some information on the downloadable instructions on the oils that we've tried that we know work for this experiment. So wintergreen and mint are two that we've used. And for each of these deli pots, you just put a single drop of the oil, just about to see that, there we go, into the bottom of those pots. Okay, so one drop in each of those deli pots. And then each pupil gets, there we go, 3 of the deli pots. Each one of those pots has got a drop of the oil in, okay? So what the pupils then do is take their deli pot, each one of those, and fill it up with water, not too full, otherwise it spills everywhere when you close the lid. It's worth having plenty of paper towel or a tray or something around to catch any extra drips or spillages. And then close the lid. And to make the fragrance solution that we're going to use in the experiment, just give those each of those pots a really good shake. And obviously do the same with the other 2 deli pots as well. Okay. What we're then going to do is transfer those solutions to our, as I said, I'm using centrifuge tubes, but you could use a vial or anything really with a sort of plastic container with a screw cap lid. You can just pour those in directly like this. And the nice thing about using these sort of pre-sized deli pots is, well, for one, they're really cheap. And 2, you know, they're not going to break, and 3, you don't need any sort of specialist equipment in terms of measuring cylinders and things like that. Okay, so what you end up with is your 3 solutions, each one 3 identical solutions of your fragrance oil, each one in the cylinder like this. Okay. What we're then going to do is add our carbon, and the purpose of this is to see how well the fragrance oil is adsorbed onto the carbon. The way we did this, again, just to avoid, obviously for pupils with visual impairment, you can buy special things like balances that actually sort of read out the display, but they are pretty expensive. So what we did, we worked out for a certain mass of carbon how many basically spoonfuls you'd need to add. So you can just get a measuring spoon or whatever. We just got a plain plastic spoon here, and work out how many of those spoonfuls you need to get a certain weight, a certain mass, and that avoids the need for any sort of specialist equipment. One thing I would suggest, and what I've not got here, this spoon doesn't quite fit into the container, so you end up sort of spilling the carbon. But so if you can get a spoon that actually fits in the container, it's a lot easier. And what you can then do is transfer the carbon to your measuring cylinder, like to your centrifuge tube or your vial or whatever, just like this. Okay, so there you go, you can see it's fizzing away. This is the activated carbon sample, so that fizzing, you can actually hear it. It's a bit like just like a fizzy drink when you first open a fizzy drink bottle. It's really bubbling away and fizzing away, and that's actually the water and the solution rushing into all those tiny holes in the activated carbon. So that's an observation actually that you can get the pupils to make. For doing the transfer of the carbon to the container, you can actually use also a funnel just to really avoid any spillage. Okay, and also again with the transfer of the solutions, you can also use a funnel if that makes it easier. Okay, so what you end up with is 3 of these containers. One of them has your fragrance solution and you've added activated carbon. We label those. Another's got your fragrance solution as a control. And then the third one has got your solution with the with just barbecue charcoal. And the point is, barbecue charcoal has a much lower surface area than this activated carbon. So for a start, you won't get that lovely fizzing that you get when you add activated carbon. And secondly, if you then leave these vials for about 20 minutes, half an hour, and then open them, what you should then find with the activated carbon, that the fragrance has dropped right off. Okay, so the scent, the smell should be much less with that activated carbon, because all those fragrance molecules have gone in and stuck to the surface, have adsorbed to the surface of that activated carbon. And that's why it's important to have this control. So obviously you can smell, well, what would it smell like if there was no carbon absorbing the fragrance? And hopefully what you should see, if you get a good activated carbon and compare it to barbecue charcoal, that your activated carbon absorbs a lot more of that fragrance, essentially removes the smell of the solution much more powerfully than the barbecue charcoal. So it's a nice experiment, just a way of demonstrating and getting pupils to sort of play with this concept of surface area and understand, you know, that some materials have these sort of lovely tiny pores that can absorb things from water in a way that is accessible. And it's a nice sort of springboard to talk about things like water treatment and, you know, what things might we want to remove from water, things like pollutants. Okay.